Okay, so you should be able to see my screen and hear my voice. I'm going to start. So I spent almost 2 hours. It is a little bit far beyond than my expectation. So I'm trying to introduce ECS and our first product to Alibaba Cloud. I spent a little bit over time to introduce ECS to just make sure people can have better understanding about this fundamental service, because ECS is actually very capable, right? It is just a running environment. So you can install database, you can install Java, you can install your web service in the ECS and do whatever you want, right? But if, let's assume one of the situations that you have a very powerful ECS, but it still cannot meet every your business requirement, right? Because just like a person, you can be a very strong person, you can be very tall, very powerful, you can do a lot of things, but you cannot do everything, right? You still need a team. You still need something can do the same thing and share the load from yourself. So the similar concept can be applied to the ECS. You cannot rely on a single ECS individually forever. In the future, when your business grow, one ECS cannot do all. You have to collaborate with several lot of different ECS together to fulfill your business requirements. That is why the SRB jump in at this time. Okay. Now let's look into the concept of the SRB. So for SRB, we have something like, firstly, I introduce what SRB actually are the applicable scenarios and some of the key components from the SRB. And after that, we show also a quick demo about SRB. Okay, so I want to say one thing about, because we are doing the online training and a lot of attendance, so we don't have the opportunity to try our products by yourself. So usually if it's the classroom training, we will have the hands-on lab. So we don't do hands-on lab in the today and tomorrow training. I will try my best to do the demo, but if you can register Alibaba Cloud account and finish one of the online quiz I just sent in the chat group, I think you can contact me. I can grant you some lab coupons so that you can try the device by yourself out. Okay, SRB, why we need it? And I said one single ECS, it has its upper limit. Right? You can scale up again and again, but finally you will reach a ceiling, right? You cannot go bigger anymore, right? And when people are coming through more and more, your customer is growing, you have to think about, I need more ECS to work together to serve the customer. But you already know that if you have several ECS, they have the different IP address, right? Each ECS, they have their own IP address. And you may not want the customer to know exactly each of these IP address to contact them separately, right? You have to figure out, how can I have something to combine them and a whole to provide the service? This something is actually the SRB, right? So SRB is a standalone and just like a middleman, like an agency, right? It is sitting inside between the customer and the ECS cluster and provide what we call the unified access point. So usually server load balancer, they have their own IP address, right? And sometimes you can even give it a domain name, right? You can give it a domain name. So the backend, so the end user can always visit this standalone and this individual domain name or IP address. They don't need to care about how many backend servers you have. They don't need to care about what kind of IP address this ECS are. They just care about, this is my endpoint, and SRB will take care of the following and backend communication and the job distribution. Okay, so that is help you to understand the SRB, the basic concept. Okay. Again, everything in the cloud, I would say it is software based. So server load balancer, no difference. It is a device, but it is a software version, which give a great benefit comparing to the hardware load balancer. So usually hardware load balancer, for sure, they are more powerful, but they are even more expensive. So SLB, considering the software version, it is much low cost. And SLB, remember, because now you see this one is sitting inside between the customers and the ECS servers. So it make its positioning very critical, right? If SLB is broken, then no one can access the backend ECS anymore. So which means the availability of SLB itself is very important. So by default, in Alibaba Cloud, we design the high availability feature for SLB, which is make sure each SLB instance, they naturally default has two nodes. One is master node, another is slave node, okay? With this kind of configuration, our customer can always have the confidence that the SRB has their own capability to do the disaster recovery. Okay, so that is HA. Scalability means on the backend server, they can extend to whatever the numbers, the SRB can handle them very easily. And security, now SRB is taking the customer's incoming request, right? Which means you cannot trust everyone coming from internet. Maybe they are a hacker, maybe they are some bad guy. So those kind of traffic need to be monitored. And even sometimes you need to filter some malicious traffics. So from SRB, we give you so-called the default DOS attack filtering for at least 5 gigabyte, right? So you can, if you, it's not a big business, you can just consider this protection from DOS attack is naturally and the default there, protect the SRB service. Okay. Architect. To understand this page, you may need to have some background about networking concept. We call them the layer 4, and the layer 7 is based on the OSI layer 7 model, right? From the OSI layer 7 model, they define the bottom layer like physical, like the transaction. I cannot remember all of them, but I know they are layer 7 and layer 4. Usually call them the application layer and the network layer. And in the different layer, we give them the different protocol definition. So HTTP and FTP and SMTP, those kind of application is more related to the human beings scenarios. We call them the application level protocol. But TCP UDP is more used to set up the connection between the client and the server in a either stable way or either unstable way. So they were called the layer 4 protocol. For SRB, this is something we will test from the examination. We support this particularly 4 protocol, the TCP UDP and HTTP and HTTPS. And we categorize them into layer 4 and 7, right? The traffic will be looking like this. This is a SRB cluster, right? When the traffic is coming through, if it is directly layer 4 traffic, TCP or UDP traffic, they will go through the green channel and they will be filtered by our so-called LVS cluster and sent back to the backend servers. But if it is a layer 7 traffic, they will go even further passes, which is they will go through the layer 4 and go through the layer 7 processing cluster. It's called a TNG. And finally, if it is HTTPS, they need to work with the encryption and the decryption process a little bit. And finally, the traffic will go to the backend server. Okay. But now you are looking at the name like the LVS and the TNG. What are they? So they are our implementation for the layer 4 and the layer 7, right? So for layer 4, we are using so-called the LVS, the Linux Virtual Server. It is a open source implementation about the layer 4 data transmission. So we use the phone net mode to transmit the traffic from the outside to the inside, right? We change the source IP address and the destination IP address from the SLB to make sure the incoming traffic, they can find exactly the backend server. Okay, so it's a layer 4. But for layer 7, we use another concept called another software implementation called TNG. TNG is based on the Nginx right? It is a developer product involved by Alibaba Cloud, and we make it also open sourced. And Tianjin is working on the layer 7. And they will manipulate and operate on the HTTP protocol, because HTTP protocol is made by the headers and the bodies, right? We do a lot of things through the protocol, and make sure you are seeing that we can support both HTTP and HTTPS, and some of the headers for the different purpose we may modify from the SLB end. There's a particularly knowledge point you need to remember for the examination is we may ask you one question about this knowledge point. So I keep saying that SLB is a device and the agency, right? Because he is sitting here to handle the two directions traffic, right? This side is internet side. This side is internal network side. When this guy is sending something to the SLB, they were building some package, right? In each of the package, especially TCP UDP package, they have source IP address, they have destination IP address, right? The source IP address is here, and the destination IP address is usually the server load balancer IP address. But when the package arrives, load balancer will change the source IP address to an internal new IP address and send it to the destination ECS. And also, which means the destination IP address will also change to the private IP address of the backend, right? Now it causes another problem. Some servers may say, okay, I really want to know my customer's real source IP address, but you already changed it from here. How can I know the exactly source IP address? This is the solution. The solution is you can just tell the backend server, you can look into a header of the HTTP protocol. The name of the header is called X forwarder 4. From there, SLB will store the original source IP address, and you can grab that address from there. Okay, so this is just one very special scenario. If the backend server want to know exactly the original source IP address, which is already changed by the SLB here, they can still get it somewhere. Okay, and to better understand SLB, not only you need to have the similar understanding about the offering. The SLB is managed and purchased also in the form of instance. Remember, we call the ECS instance, and SLB is also managed by instance. But inside SLB instance, they have some internal component. The most important internal concept is called listener. Okay, because previously I said SLB can support layer 4 and layer 7 TCP UDP, right? So listener is exactly to define which exactly protocol they are listened to. So let's say HTTP is one of the specific protocol the listener one will listen to, right? And on the backend, we will make sure each of the backend server, they have exactly the HTTP service, right, running there. And also they should export so-called the port, right, P-O-R-T, the port at 80. And from the front end, maybe this listener will not only listening to HTTP, but also they will say, I'm going to listening to the port 82. With this kind of configuration, the end user will only need to talk to this listener and send the request here through the HTTP and the port 80 to the load balancer. And the listener will distribute the traffic to every backend servers based on some scheduling rules, right? So now you have another listener in the same load balancer. They may listen to the SSH protocol with the port, which is 20, right? which means from the green lines on each of the backend server, they should also have something called the SHD, which is SSH daemon, listening to the port 22, right? But with this, you can set up the listener to listen to the different protocol and send it back to the exactly backend service. Okay, so remember, this is a very important component. It's called the listener. And the backend server, I do not need to explain too much, right? And similar like the ECS, you need to think about what kind of cost I can afford for SLB, right? So again, for SLB, we support pay-as-you-go. Really, please really be notified that we don't support subscription mode SLB, right? So you see there's no subscription mode because SLB is based on the traffic. So pay-as-you-go is more reasonable. And again, we have two choices here. The one choice is public SLB. Another choice is private SLB. The major difference between public and the SLB from the name is if you buy a public SLB, the SLB has the public IP address in it, okay? If you buy a private SLB, usually it's free, right? And which means this SLB only have internal IP address. There's no public IP address, which means they cannot be visited from internet, but they can be visited from internal cloud network. The benefit to give you the two choices about public and private is we help you to be able to organize a infrastructure like this, right? Each of the service, if they are not external service, you can use the private SLB to make them together, right? This is called the internal service. But some service, they may facing the public, you can use the public SLB. And put them all the service together, you can have a very flexible and elastic microservice architect build, right? Okay. And now let's go to see the scheduling policies. I see some student is asking, I mean, you guys are asking the question from the chat box. So you already know the concept of the listener, right? So how can the listener distribute traffic to the backend? So the first thing you need to care about is the forwarding rules, right? Like the scheduling. How can you do the scheduling? We support 3 kind of forwarding rules. The first one is round robin, easy to understand, right? Just 1, 2, 3, 1, 2, 3, equally shared responsibility. But another more reasonable scenario is maybe the backend server, they are a little bit different. One CPU, one server is 2 CPU, one server is 4 CPU, another one is 8 CPU, which means you may want to give more workload to the stronger ECS. So we give you a capability called the weighted round robin, which means you still do the round robin, but you will always give the bigger one, give the powerful one more workload based on the weight. So every ECS was assigned with a number of the weight. The bigger the weight, comparing to others, he gets the more load, okay? And the third one is called the weighted least connection. Weighted least connection means considering the history. For example, it's just like you are working in a company, right? If you are a boss, if you are a manager, who you are going to assign the work to, maybe you can consider his historical performance. In the future, in the history, if this guy didn't do too much work, you may want to assign more work to him. So this is a history-based assignment mechanism, right? In the future, in the history least connection you got, you may get more traffic in the future. 3 different major scheduling algorithm. Okay, so you know this one. So session stickiness. Sometimes in the examination we may ask also. So what is session stickiness? Session stickiness means in the HTTP level, sometimes the client and the server side, if they want to save some extra efforts like the login verification, because every time you don't want to verify your server's availability and authentication every time when you connect to the server, you may, after the first login, you may mark the connection between this client and this server with a specific cookie value. It's called a session ID. Every package have the same session ID. You can assume that they may coming from the same communication channel, and you will assume this is safety communication. This session is very valuable, right? It gives the customer even more better user experience. But regarding to the load balancer, we have the scheduling rules, right? If you don't let the SLB know the session information, the SLB will randomly distribute the traffic, which will break the relationship between the client and the server. Okay, so the session stickiness is the feature that you can tell SLB that, okay, guys, I don't want you to distribute my traffic randomly. I need to know that for every same session traffic, please keep sending it to the same server. So that is the idea of the session stickiness. You open it and the SRB will make sure the same session, they will test and detect the session ID through the cookie or some other values and make sure they were sending to the same backend server and make the customer experience even better. And the third one is about health check. Every ECS working backend on the SLB just like a motherhood, right? He has a responsibility to make sure his children is healthy. If one of the ECS is not working anymore, he shouldn't send the request to that unhealthy ECS anymore, right? Which means we should keep monitoring the health status of the backend ECS, and something was happening, they will stop forwarding the traffic to the ECS, so that whatever the customer is sending, and there will be no miss sending to the unhealthy traffic, unhealthy ECS. Okay, and the last one is the peak bandwidth. Peak bandwidth means in the load balancer you can have a total bandwidth to be defined, right? But each of the listeners, since they are listening to the different protocol, maybe they have a different business priority. So for this listener, you can give him maybe 50 megabyte. For this one, you can give him 100 megabyte. So they can share maybe the total 150 megabyte from this balancer bandwidth. So different business is taken care of by the different quota of your bandwidth. Okay, that is all I want to share for the listener. For the SLB, and what I'm going to introduce here. Sorry for the noise. I have some noise on my home. Let me show you this one. I'm going to go back to the SLB. Give me 1 minute. I'm going to put on my earphone, and I may, filter the noise a little bit. Sorry about this. Okay, I will make sure you can still hear me. I'm going to show you the SLB console. It's here. Now you are looking at the SLB console, and just and the demo purpose, I'm going to create an instance for you directly. Now you see, for the SLB, the first question we ask is still which region you want to put it in. I put it in Singapore region, right? And again, and I said SLB has to be HA, has to be high available. So we, by default, we mandatory put it in the multi-zone, which means for one instance, you have two nodes, the primary node and the backup node. Okay, we put the primary node in one zone, you can pick up, and another zone has to be different, right? A and B. If you choose to B, there will be C and A, right? It has to be different. Okay, And we give a name like, again, Malaysia demo 1, right? And now you see the concept of internet and intranet. Internet, you have public IP address. Intranet, you don't. And you can specify a specification which is based on the bandwidth. I can use the shared performance one, but I'm not sure if they have the enough storage. I will pick up another one. Okay, another one. Really, come on. Another one. Come on. Let's change the zone. Okay, it's now coming back. Never shared. Okay, you got it, right? And other things, I think it's not very important. So you get the idea here. Has to be HA and could be internet or intranet. Let me see the intranet. For intranet, it has to belong to one of the VPC and one of the connected vSwitch, right? So let's go back to the internet and pick up the configuration, and I can go buy now. And you see, I can go the active now to make the SLB take effect. Now I can go back to the console. I should go back here and refresh. Oh, come on. Okay, anyway, I go here. I see the load balancer, right? Now this is one I just created. Again, this is just an empty SLB instance. It cannot do anything. If you want to use it to forward the traffic and distribute the traffic, it has to be configured first. What you are going to configure is exactly the listener, right? So now you are looking at the listener configuration. Remember, if you want to configure the listener, you also need to specify the protocol. For each listener, it can only listen to one specific traffic, which is a protocol. I pick up HCP, and I tell the listener you need to listen to the port 80, which is a common port for the HCP protocol, right? And the name could be just give it a name. And here is other features we mentioned in the slide, right? You see weighted round robin, weighted least connection, round robin, and they don't support the constant hash for HCP. And this is the session persistence. You see, you can enable it by saying that what kind of a cookie you want to make sure you are using, right? And also the peak bandwidth limitation. Remember, you can do the quotation for your different listeners. After you do, you can see here, this X44, remember, you can use it to retrieve the source IP address. After you make all these decisions, you can go to the next. Next is talking about the backend servers. The backend servers, usually we do the default one. It is no difference from the backend server. And you need to add the ECS to your listener. And all the ECS will come from the same region and usually should come from the same VPC, right? You see, I can pick up whatever I have, like this one, and let's just pick up two, right? I click next. I'm doing two ECS adding to my to my listener, and I need to define the weight. Remember, weight means they have different workloads to be handled. If they have the same value of the weight, which means they are actually share the same load, 1-to-1, right? But if I change it to 1 to 50, another one to 100, it will be 1-to-2, which means this one will get two times of the workload than this one. And you can click add. Now you define the weight, right? And you also need to define which exactly port from the ECS point of view they are listening to. Remember, at the front end, we have 80, but on the back end, it could be 80, could be others. But usually, if you have the service running on your ECS, it should be listening to the 80, generally speaking. So I put 80 here, and this two parts should be the same, always the same, so that the listener can always know exactly the same port I'm trying to forward it to. After you make all these decisions, you click next, and you have almost everything done. But before you click the submit, there's a health check I mentioned in the slides also, right? You enable the health check. For the HTTP7, you can enable it and you can disable it, but for the layers 4, you cannot disable it. It has to be enabled. And you can modify what kind of mechanism you want to use to do the health check. The return code, the interval, frequency, those kind of values you can always modify. After you make all this decision, you can click next and click the submit. Right? Now you have your first load balancer configured with two servers. Right? And this is what I'm going to show you on the demo. But this one, I don't have a real service running on it. So it looks like a little bit not very vivid, right? What I need to do is I'm going to show you how can I set up a real environment. So in this time, I'm going to go back here and show the lab environment. Okay. Again, if you want to have some lab coupons, please make sure you at least finish one of our online quiz. I stand in the chat box. So if later on you can show me you finish the online quiz, I can grant you some lab coupons. The lab I'm going to show and a demo here is called the ECS plus SLB. If you go to the labx.io, you found the lab from the top line from the second one. And after you register yourself for this website, this is not Alibaba Cloud website, it's a third-party partners website. Collaborate with us. You log into your own account for this website. You can using our coupon to buy this lab. Okay. What I'm going to do is I'm going to use this lab to show you how can I set up a real environment for the SLB and how SLB will distribute the traffic very easily. So firstly, I will log out from my previous login, make sure it not interfere with my lab environment. I log out from my previous console. And okay, then I'm going to start my lab here. Sorry for the noise. Someone was decorating their house. The deployment means on the back end, this lab environment is trying to create some necessary cloud resource. Usually it is ECS. Maybe in this lab, it is SLB. Okay. And in this lab, I'm going to do this kind of setup. And in this lab, I'm going to do something like this. Firstly, there's will be one SLB instance already created in the lab. And also at the same time, two ECS will be also created already by the lab. And what I'm going to do is I'm going to create a listener, okay? A listener in the SLB and config the listener with the two ECS. And in each of the ECS, I will create a Apache web service, okay? I will create a Apache web service and listen to the port 80 with the HTTP protocol, similar here, right? HTTP protocol. I will configure the listener to listen to the 80 and to listen to the HTTP protocol. And then later on, I'm going to visit this SLB from the outside, and you will see the traffic will be, scheduled one by one from each of the ECS. That will be the lab I'm going to do right now. So here you see the deployment of the resource is done. And what I need to do is I click the button from the open the console, and they will lead me to this login console. This is not a major account login page, so it looks a little bit strange. What I need to do is I go back here and copy the temporary Alibaba Cloud account information. You don't need to have your own account. I will prepare the temporary account for you. You click the name here and copy it before the before this symbol. I forgot how to pronounce it in English. And you click next, and you copy the password from here, and then you go to here, right? And click login. Okay. What you are looking at is another Alibaba Cloud Console based on my login name and password. What I need to check out is, firstly, I want to check out my SLB, and also I want to check out my default resources of the ECS instance. In our lab environment, we will prepare two ECS, and these two ECS will be shown in the US Silicon Valley region. And the SLB also, we need to check out from the Silicon Valley region. This is very important. If you cannot find your SLB, you need to go there. I'm not sure why my Melissa, yeah, okay. Let me go to the instances. And I'm going to change the Silicon Valley region. Now you see, I have two ECS. They are Linux servers, right? They have public IP address here and here. I also have one SLB instance here, but it's not configured with the backend server yet, right? So what should I do? Because I'm following the lab instructions, so I can go through the instructions from the lab page. There are some pages I can skip from the very beginning and start here. Let me stop here. Okay, so the lab is suggesting us to try to install some Apache server in each of the ECS, right? Okay, so I'm going to follow this instruction, and using either WinC or using the terminal from the Mac laptop to log into the ECS, right? So, but how can I log into the ECS? Where is my password and username? I give it to you. For the Linux, we give the root and the password here, right? Now, let's use my laptop, and I'm going to start a new one. Okay, I'm going to exit and create a new new page. Okay, so I have to clear. I clear this. So now I have two terminal, right? I have two terminal. So I'm going to log into each of my ECS from here. So the first thing I'm going to is copy this public IP address, sh root at this one, and yes, and the password is from here, right? I copy it from here, and I Control V, and I get in the ECS. Now I'm going to do the same thing to another ECS here, copy and SSH root at this password, sorry, this IP address is another ECS, and yes, and I have to copy the root password again, right? A little bit slow. Okay, then I copy that type of ifconfig to make sure I'm in the right ECS. So this one is 1.174, and this one is 1.173, right? And we go back here, and check out, okay, this one is 174, this one is ended with 173. We are in the same ECS, in the right ECS. So what I'm going to do next is follow the instructions to do so-called the Apache installation. So I need to execute the command on the both sides, on each of the ECS. So I just copy once and paste twice. The first command is to do the software upgrading, right? I do the upgrade, right? Another command I want to do is using the Ubuntu apt-get command to do the Apache installation, right? So it is here, I copy it here. And also I copy it from another ECS. The Apache installation is quite simple, just one command, and you will be able to have your HTTP server running on the ECS. Sorry again for the noise. Then let's check out the Apache server status. You run this command and you see it is running, which means, okay, it's there, right? Also on this one, I tap the, it's also running, right? Okay. So once we say there are two servers running on the ECS, we need to check out from the browser, right? How can we do that? We copy the public IP address to the browser and we paste it here and we click return. You see, this is my Apache server's front page. I can do the same thing. I can copy another password, another public IP address here and put it in the browser and you type the return. You see there's another Apache server running. But these two pages are the same. I cannot distinguish which one is which one. So I may do a little bit of trick, right? To change the front page to make sure I can exactly distinguish the server 1 and the server 2. What I need to do is I go here and follow the command like this. I go to this special directory, which is the Apache server's working directory. And you need to change the front page, which is index.html, right? You just change it to the server 1 and you change another one to the server 2. But to make the things easier, I will VI and okay. This one is a little bit slow and I will make it server 2. Okay. Now I have this one is called the ECS2, right? And I have this one called the ECS1. But to verify my change, I can refresh the page here. You see this one is ECS1, and I refresh my page here, and you see this one is ECS2. Now I have two exactly different service running on the two ECS. After you do this configuration, you can go to the SRB configuration, right? The SRB configuration will be quite similar like what I did from my own console right now. So I'm going to do this quickly. So you can see here, I'm going to configure my SRB. I click here, config. I will use HTTP from port 80, right? And I leave this as default and I go to the server side and I add my existing two ECS to my backend. And check this out. The ECS don't have any public IP address, right? But SLB has, that is enough. And I go to next and give them the weight 100 to 100 and I click add. And the port they were listening to is 80, right? So it is Apache default port. I move this here. Then I click next and click next and click submit. It's just as simple as that. After you do this, you are configuring SRB with two servers running on the backend with Apache server also running on the port 80, right? Which means now I set up this kind of quick configuration like this, right? Now I need to visit this service, but from where? I need to visit this service from this public IP address, right? So I copy it from here. This is SLB public IP address, okay? It is not ECS public IP address. This is SLB public IP address. I put it on the browser and I click return. Now you see the backend server is responding, right? Even I'm visiting SLB, I'm getting the response from one of the servers called ECS1. And if I use this button, the refresh from the browser, I click, and you can see with the scheduling mechanism, the server 2 is responding, and I refresh, the server 1 is responding, and I refresh, the server 2 is is responding. So it is a weighted round robin, right? Because the two servers have the same weight, so they are responding one by one, right? So I go to my configuration, and this is strange. Let me check out. Wait 1 minute. I want to change the weight of the ECS, okay? I go inside, this is the listener, okay? I'm going to modify the listener, right? And I don't change anything for the server, for the portal. I just want to change here. I want to change one of the ECS with a weight 80, another with 100. Now they are not balanced, right? One take more job and another one take less job. So I just make the change and click submit. After I do this, if you go back to the SLB page, when you do the refresh, 1, 2, 3, 1, 2, 3. Now you see the server 1 is taking 2 response, and the server 2 is taking only 1 response, right? But because I'm from the window, so it is not easy to check it out. You can see here, 1, 2, 3. I click 3 times, but ECS1 take 2 response, and ECS2 try again. 1, 2, it's still 1, right? Then 3, it is ECS2, which means the weight is changed from 100 to 50.